Hello everyone and welcome back to Bell Explains. In today's video, we'll be talking about Newton's law of gravitation. Newton's law of gravitation states that the force experienced between two bodies will be directly proportional to the mass of the two bodies. Okay, so F is directly proportional to m1 times m2. So if you have two objects, then m1 will times m2. And F is also inversely proportional to the square of the distance between the center of the two objects. Okay, so to define these two relationships that Newton has come up with, we're going to combine the first relationship, the directly proportional one, and the second relationship, which is the inversely proportional one, together to make it a definition. Okay, so look at the first one. Force is directly proportional to the product of the two masses of the body, and it is inversely proportional to the square of the distance between the two bodies. The radius is not the radius from the surface of the two objects. However, it is the distance from the center of the bodies. From the center of the first body, and it goes all the way to the center of the other body, including the radius as well. When we change relationships into equations in formulas, we're going to have a proportionality constant, and in this situation our constant will be called gravitational constant. We provided in SPM, so you don't have to memorize the value. Okay, gravitational constant is constant. It's going to be the same throughout any question at all. The value will be 6.67 times 10 to the power of negative 11. Next, we're going to derive the units that is for the proportionality that we used just now, gravitational constant, G. So G was 6.67 times 10 to the power of negative 11, but it does have its own units, which we will need to derive maybe in paper 2. Gravitational constant, it's our unknown that is on the right hand side, which means that if we're going to derive it, we're going to have to make it the subject. So every other variable that's there, which is m1, m2 and r square, will have to move to the other side. Okay, do also take note that m1 is typically used for capital letter, which is mass of Earth, and the small m, which is m2, will be used for an object. So for example, I have the Earth and I have a satellite and I want to calculate the gravitational constant, then m1, which is the capital letter, will be for the Earth, and m2, which is the small letter m2, will be for the satellite. SI unit for force will be in Newton, and the SI unit for distance will be in meter. But since it's in radius square, it's going to be meter square. And for my denominator, I have mass times mass, which is going to give me kg square. So when I derive my units, I will have the numerator, which is Newton meter square over kg square, right? So when you combine your units together, this is what your unit will look like. Okay, nm square kg negative 2. Okay, let's try an example. Example 1, calculate the gravitational force between a durian and Earth. If the mass of the durian is 2 kg, they will have to give you the other values. So in this question, they've given us the distance between the Earth and the durian, which is 6.37 times 10 to the power of 6. This number is very large, mainly because the radius of the Earth is already very long. It's very large. The first thing to do always is to make sure to write your formula. So in this case, our formula is F equals to G m1 m2 over r square. Do standardize that m1 is mass of Earth always. Okay, so substitute our values. 6.67 times 10 to the power of negative 11 for gravitational constant. m1, which is for Earth, so 5.97 times 10 to the power of 24, which will be provided in the formula segment of your SPM paper. And mass 2, which is for durian, 2 kgs over r square. Don't forget to square your radius because that is the formula. Most common mistake done is that the square is omitted. Okay, then when you calculate, you'll get your final answer, which is 19.63, and your unit has to be in Newton because that's the SI unit for force. When you calculate your answer using a formula, make sure that everything that you substitute in there is in SI units so that it doesn't get confused. Because our gravitational constant here has all the SI units, which is Newton meter square per kg negative 2. So your distance has to be in meters, it cannot be in kilometers. And your mass has to be in kg, cannot be in g. Okay, so you have to be aware on that kind of things. A rocket at a launching pad experiences a gravitational force of 4.98 times 10 to the power of 5 Newton. What is the mass of the rocket? Okay, so in this situation, remember I told you that M, the first M, which is for Earth, and the second M will be for any object. Could be a durian, could be a rocket, could be a satellite, could be anything. Okay, so in this situation, we're gonna isolate our variable, which is for the mass of the rocket. Okay, so we'll bring M to the front and everything else stays to the right. We're gonna substitute all of our values into our formula once you have derived it, and our answer will be 5.07 times 10 to the power of 4 kg. For mass, our SI unit will be in kg, so you have to write your unit. If you give your answer without the unit, your answer is not accepted, it's still considered wrong. Okay, so that's all you need to know for Newton's law of gravitation. If you'd like to learn more for Chapter 3, Form 4 Physics KSSM, you can join us in our next video. Thank you.